70 light years from Earth, we reach Aldebaran, a red giant entering into the last phase of its life. While it is slowly running out of fuel, it will start swelling up and losing its matter into space, a process that takes millions of years. Everything has its own pace in the universe. We've already covered 100 light years, 200, 400, then we come to the Pleiades, the calendar stars of the cave dwellers and the Egyptians, a few bright stars in a cluster of more than 1,000 stars. They were all formed together, and they are still wandering together through the Milky Way system. All the stars are moving constantly, even our sun. Veils of thin gas, helium, hydrogen, they're all drawn out into fine trails in which hundreds of thousands of stars glow. Here is the sixth star of the hexagon, Rigel, a blue giant, 1,000 light years away and 100,000 times brighter than the sun. How long it took us to understand that distant objects can be so enormous. The interstellar gas grows thicker, and it is joined by dust, fine particles microscopically small, but making up a huge mass altogether. The smoke from gigantic explosions in space. Pressure waves compress the gas and dust so densely that they form nebulae and dark veils. These enormous opaque clouds are the birthplaces of stars. This is where new stars are being born out of gas and dust, star by star, sun by sun, each of them different, most of them with planets. Newborn stars blast off all the gas and dust surrounding them, ready to form new stars one day. An endless recycling process of matter, just like our own sun was created a long time ago. A giant star, much larger than our sun, explodes as a supernova. Its core collapses, and from the ashes of its shell, the process of star formation begins anew. the interstellar gas and dust get more compressed, nebulous arms and giant tentacles form. These are the spiral arms of the Milky Way, our own home galaxy. A wafer-thin disk made of gas, dust, and billions of suns, and our own sun is just one of them. There is a glow on the horizon. It points the way to the heart of the Milky Way, hidden behind black dust clouds of matter. The center of our Milky Way is dominated by extremes. Millions of stars are circling a small black spot at mind-boggling pace. Here is the black hole at the center of our galaxy, a mysterious place with such a powerful pull that not even light can escape. That is our Milky Way in all its glory, with its spiral arms made of stars, gas, and dust. Together with all the other stars, our solar system follows the eternal spin of one of the spiral arms too. We are slowly and endlessly orbiting the center of the Milky Way. We humans, our Earth, are all a part of the Milky Way. Our sun is one of a billion suns. And since we're sitting in a region halfway from the center, we see the Milky Way as a narrow, glittering band across the night sky.
I am most impressed, my dear friend. I've always thought that you must have spent all your time in the corner of a physics lab.
Oh, not at all. I was always trying to solve the great riddles of the universe. Dark matter, for example. Or the question, how many planets are there in our galaxy? Or a problem that really affects everyone. Are there asteroids on a collision course with the Earth?
Yeah, that seems to be a real problem, one that people have always underestimated, that comets and asteroids might threaten the Earth.
Really, and a lot of those objects are still unidentified. What good is it if we don't discover them until the last minute? We need much more precise measurements if we want to be able to make reasonable predictions.
But that should be no trouble with modern technology, shouldn't it?
Of course. As soon as our Hipparchus mission ended 20 years ago, we started the next one. And this one pushes up against the very limits of what technology can accomplish. Gaia is its name, our new satellite.
I knew you had an ace up your sleeve.
Gaia will, for instance, discover thousands of asteroids and deliver us the precision we need for collision warnings. But its main purpose is to draw a new three-dimensional map of the Milky Way. Gaia will help us find out more about the origins of our home galaxy. Right now, there are all sorts of theories out there because the measurements are so imprecise. But Gaia can measure the paths of the stars so precisely that we'll be able to retrace where the stars in our galaxy came from and where they're heading in the future.
You mean a sort of archaeology of the Milky Way?
Exactly. But for that, we needed a whole new approach. Gaia is a 3 by 3 meter cylinder with a solar panel underneath. Inside the body, there is a super rigid structure made of silicon carbide with no moving parts, everything designed at extreme precision. And right in the heart of the spacecraft, we have a gigapixel chip, 106 chips in fact, photosensors like in a digital camera, just much bigger. It's connected to 10 ultra-high precision, polished telescopic mirrors. That is technology at its very best. Tailor-made by the European Space Agency and the best industry laboratories all over Europe. Over 1,000 people have worked on it for years. Gaia is so precise that it can measure from 1 meter away how much your hair has grown in a fraction of a second. And this precision will allow us to measure quite precisely the positions, movements, distances, brightnesses, and colors of 1 billion stars. 1 billion stars, just imagine that.
1 billion stars. Hard to imagine. And that people are able to build something like that. Incredible.
Unlike earlier times, we don't define a fixed background. You remember the story with the fixed stars behind your thumb?
Yeah, but what is your point of reference?
We treat all stars as reference points. We measure the parallaxes, the angles in the triangle, individually for every single star, and we work out all the references and motions together. Finally, we are computing the positions, motions, and distances for every individual star using mile-long calculations, a calculation with 700 million variables. That is leaps and bounds beyond anything we have right now. Every day, our supercomputers calculate billions of triangulations. I can see you wince at that thought. On top, our data have to be corrected billions of times over with the positioning data from the satellite and other error factors. 1,000 billion shots, enough to give even the most powerful computers a nervous breakdown. That is a Herculean task that takes years.
Which I do not envy you for.
Not to worry, it's spread all over Europe. Hundreds of scientists are working on it. Enormous computer clusters.
And what do you expect to wind up with?
You won't believe it. In the year 2020, we're coming out with a table containing 1 billion lines and several hundred volumes. Like a gigantic Excel spreadsheet.
Nothing but a spreadsheet? You must be joking.
No, that is really what we're doing. On paper, it would fill up 2 million ring binders. Anyway, we are putting together a brand new database of the Milky Way. And these columns of super precise figures will be used by astronomers all over the world to discover new objects and develop new theories.
Such as?
Oh, there's a whole series of them. The asteroids and supernovas I've already mentioned. We also believe that the Milky Way dates back to the very beginning of the universe, but we don't know where all the stars come from. With Gaia, we'll be able to retrace the movements of the stars, filter out the movement of outside stars, and finally come to fully understand the history of the Milky Way and its future. And on top of that, we plan on discovering tens of thousands of planets, because one thing is clear, there must be countless planets in the Milky Way that resemble Earth.
So you are truly searching for extraterrestrial life?
Oh, of course we dream of finding life. But with Gaia, we're simply laying the foundation for the real discoveries in the future. Like I said, measurement is knowledge.
Measurement is knowledge. I didn't know what physics is really capable of. Consider old Hipparchus with his star map. Who would have thought this would teach us so much? You know what? In my next income,